Hi everyone, can you hear me? If you can, please post in the chat. For some reason my camera refuses to turn on, but if you can hear me, that is good. Okay, so hi guys, welcome back. Mehrab says he never left. That's awesome. Good. So I just wanted to say a couple of things. If you're tuning in right now, we're about to start. Hi, Alex. So we've got David from Request speaking. There he is. Hi, David. I've just posted David's Twitter in the chat. And we should probably also get Request's Twitter in there as well. Hello, how are you guys doing?
Doing well today. How are you doing?
Awesome. Not too bad. I'm not sure why my camera's not working. But I think you guys have seen my face enough in the first part of this workshop session. Awesome. So I guess, David, whenever you're ready, you can go ahead and take over the screen.
Sure. Sounds good. I'll just jump right into it.
Mm-hmm.
Share. Let's try this. Can you see my screen?
Yes, we can see your screen.
All right, cool. Okay, so hello everyone. I am David Hunt-Mateo, also known online as Mantis Clone, and I'm a senior blockchain engineer at the Request Network Foundation. And briefly, I'll introduce my co-contributors here. Alex is our community manager, and Francisco is the protocol lead. And we're here today to talk a little bit about what Request Network is, describe a little bit about how to use it, and hopefully get you guys hacking on our protocol as soon as we can. Basically, what is Request Network? It is a protocol for creating a transparent and immutable ecosystem of financial products on top of it. The basic issue with blockchains today is that when you create a transaction between two parties, you don't have the information about why that payment is occurring or any other sort of metadata that you would want, like the names of the participants or the addresses or tax numbers or whatever other information you would want to add to it. And all of this information is the sort of stuff that is necessary for business accounting, business compliance, and other financial services like proving income and being able to borrow. And this is a challenge. This is a challenge for businesses these days. So what Request Network Protocol is trying to do is we are creating a channel for that information to be stored immutably and being able to make it both composable as well as private to the parties who are needing it. And by storing this information, we are unlocking new applications for blockchain, including the ability to have income-backed loans, insurance, fundraising, and even further out, we imagine a world where there could be automatic auditing, triple entry accounting, and automatic tax reporting. I could briefly talk about what those things are. Automatic auditing obviously is like the ability to show that your business has the required assets or the assets that it says it does. Triple entry accounting is the idea that instead of having an accountant who needs to aggregate all of your financial information and then like do a bunch of calculations at the end of each month and reconciliation activities, all of that can be automated, and they are instead reviewing the information rather than inputting it or calculating it themselves. And then finally, automatic tax reporting. If you've been working in blockchain for any amount of time, you probably have already used a tool that generates tax reports. And I think that our protocol can only make that sort of information better. It helps you understand what is income versus what is something else, maybe like capital gains of some sort. So yeah, request network, we're the basic idea of how it works is that we've created a standard for storing payment information, including like the payee, the payer, the due date, the currency, and the amount, and it stores all of that sort of stuff in IPFS. And then we take the content identifier, the hash of that information, and we store that on chain, typically on Gnosis Chain. So once the information is stored, we also have a series of smart contracts that we use for executing payments on those requests. And the payment proxy contracts are deployed to over 20 different EVM compatible chains, as well as near. And once a payment occurs, because it goes through our smart contracts, events get emitted, and then we have a series of subgraphs from the graph that index the events and then are able to return information about those requests when you query for them. And some of the things that this enables is you can create invoicing apps, you can create payment apps, you can create accounting apps, you can create tax reporting apps, a whole bunch of different stuff across the financial spectrum, which brings me back to my original point. By creating this shared data layer, we are creating a transparent and immutable ecosystem of financial products on top of it. So I will dive right into some of our Quickstart, our documentation here. We are working on a quick start, but in the meantime, we've got a couple of guides that we can show you. The first one is how to create a request. Basically, we have actually, you know what? Before I do that, I'm going to rearrange my topics just real quick because I realize I need to talk about installation first. Okay, so the way that you interact with the request network is using our request client library. The request client library, it's written in TypeScript, but you should be able to access it as both a UMD module or a common JS module, whatever your project is set up to do. I've got some instructions here on screen that allows you to install the request client, as well as a accompanying package called Web3 Signature, which most dApps are probably going to use. You'll notice some weird versioning information at the end here. The honest truth is that we have an automated release process for our packages, and we haven't done an official like numbered release in a while. So the best way to get the latest code is to actually just use this special string with the next in it and the 1892. That will give you the latest version of the code. Basically, it's you import it the same way that you would any other client library. You can see this line right here. It imports the request network, and the line after it imports the Web3 signature provider. And once you have it imported, you can instantiate those objects using the following code snippet. The first thing you'll do is create the signature provider and hand it the injected wallet. So that's going to be window.ethereum. And then you're going to create a request client, and you're going to pass it the URL of the request gateway that you're using, along with the signature provider. And just some notes about this: the URL. This is a request node gateway that's maintained by the Request Network Foundation. This is maintained by us so that builders can quickly get up and running with the network. The idea is that once a project has reached a certain maturity point, they would eventually want to run their own request node on the network. But I'll leave that as a future topic if any of you decide to continue building with us after the hackathon. Some other alternatives to describe here is that the idea of the Gnosis chain gateway is that we also have a Goerli gateway if you want to create testnet requests. These are requests that are created using testnet funds, and then typically would be for paying on testnets. That's an option that you could use. And if you want to manage your own private keys outside of a wallet, we also have a EPK, Ethereum private key signature package, which would be the analog of the Web3 signature package. That's also an option. Another thing that I want to note at this point is that you can create requests on Gnosis Chain or on Goerli, but that doesn't mean that the payment must occur on Gnosis Chain. We have our payment proxy contracts deployed to over 20 different EVM compatible chains, as well as Near. We also support Near as of very recently. So payments can still occur on any of those different chains in a variety of, native coins, ERC20 coins, or with a variety of other payment processing features that I'll get into later. So with that, I'm going to jump back to the quick start that I was originally talking about. We're going to want to figure out how to create a request, right? So in order to create the request, there's a guide here that I'm showing on screen that'll show you how to create, in particular, an ERC20 request. And admittedly, this guide is using a few different things from what the installation talks about. This one's using the EPK signature provider, so it's going to have the Ethereum private keys managed outside of a wallet. It's also got the this particular guide is using mock storage instead of the Goerli, instead of the Gnosis Chain gateway, but either one would work. If you're just trying to understand how the library works, using mock storage can be nice because it stores all of the requests in local memory on your machine without actually having to go out and ping IPFS to create. So it's a lot faster to iterate, but keep in mind that all of the requests that you create in that way will be deleted as soon as the script finishes. Okay, so I mean, basically, you import it very similarly to what I showed on the installation guide. You can create a couple of identity objects that describes the type of identity, the Ethereum address, and then provides the actual address. And then you have a signature provider that has the private key that's going to be signing the requests, and you create the request network instance, giving it both the signature provider as well as telling it to use the mock storage. So with that, I'll talk a little bit about what the information a request contains. You can see that there's just a few fields here: the currency, the expected amount, the payee identity, and the payer identity. This is very bare bones. Obviously, the core protocol only requires these four fields. But we have the ability to add additional content into any given request. And that content can be, it could be arbitrary or defined by the application that you're creating. We also have data formats, pre-built data formats available in our repository for creating things like invoices. And an invoice is going to contain a whole bunch of other information like line items, amounts, discounts, tax percentages. It's going to have information about the payer, like their address or their business number or their VAT number, tax number. There's a whole bunch of different fields for all that sort of stuff. So I could drop some links later of how to find those data formats. The primary way that you're going to create requests is probably going to be using our proxy contracts for payment. Technically, we support a different address-based payment mechanism, but I won't get into it today because nobody uses it. Basically, the way that you create a request is you just have to prepare the creation parameters. You specify the payment network that you're using. Basically, that's going to be the chain, the currency, and any of the payment features that you're going to be using, whether it's a native token, an ERC20 token, or if you're going to be using conversion, escrow, or doing any sort of swaps as part of the payment. You're going to provide the request information. That's the contents of the request. And then you're going to provide the signer, the payee that is creating the request. And then you just call create request on your request network instance. It's basically as simple as that. Once it returns, you'll have a request object that contains a description of all of the things that you passed into it, along with any sort of event information that have occurred on the request. Briefly, I'll talk about some of the events that could occur. Is like if a payment has occurred, that'll be returned. It technically has the ability to increase or decrease the amount. Those are other actions that can occur on the protocol. Or if you want to, if the payer wants to approve the request and show that they are accepting it as valid and not spam, they have the ability to do that. Finally, the payee, the creator of the request, also has the ability to cancel it if they want. I will get into balance checking in a future section. So I'm going to jump back to the quick start. The next thing that I want to talk about is retrieving a request. Excuse me. When you're retrieving a request, you're going to be making calls on that same request network object, that request client object that we created earlier. And some of the functions that you could use are the from request ID function. This one is going to retrieve a specific request by ID. And the request ID is something that would be passed back to you when you create the request. Or if you know all of the parameters of a request, including the request info, the signer, the payment network, any topics or content data that you passed into it, you have the ability to compute what a request ID would have been. So then you can use that ID to look up any query the network for the current status of that request. And you can see in this usage example just below, once you have queried the request by ID, you can, oh shoot, I think it's in a later section. I updated one of these, or maybe I didn't. One second. Maybe I haven't refreshed. I was working on the docs just before this. Okay, here it is. Here it is. That's the line I was looking for. So once you have the request, you can call the get data function on it, and that will return the actual data stored within the request object in a format that's much easier to parse. So the request data that you're going to get is going to be stuff like the currency, any metadata about the request, the current balance. So that's going to be how much has been paid against that request. You're going to get the content data. That's the extra stuff that I talked about earlier, like the line items or the addresses and stuff like that. You're going to get information about the currency, what chain it's on, the ERC20 address, if there is one, and other parameters. And then you're going to find out whether or not the request is pending, meaning whether it's been accepted by the payer or not. Okay, that's how you look it up by ID. There's also instructions here for if you want to look up all of the requests for a given Ethereum address. That's also an option. You call the from identity function. And so when you're calling this, you would pass in the address of the Ethereum address that you're using, and it's going to return back to you an array of requests from which you can then call the get data function on each one of them. Okay, so that's pretty much all I want to say about retrieval. I'm going to jump over back to my quick start. I'm going to go over to the payment processing part of the presentation. When you want to pay a request, this is something that the payer would have the access to do. There's a bunch of different ways that you could pay it. And I kind of alluded to it earlier. Our payment processing networks support a variety of different features. Like you can pay in the native token on whatever chain you're on. So for Ethereum, that would be ETH. For Polygon, that would be MEC. You can also pay in any of the ERC20 tokens that exists on those networks. So that would be like your USDC, USDT, or any other token that has been created. REC, for example, REC is an ERC20 that exists on Ethereum. That's the native. That's the protocol token for Request Network, by the way. We also have the ability to do conversion, and conversion is a feature where the request is denominated in a currency other than the one that it's actually paid in. This is useful for accounting, where most accounting systems denominate all of their payments and requests and invoices in USD or some other fiat token. So what our conversion network does is it integrates Chainlink oracles, price feeds, so that you can determine the exact amount of a particular currency to be paid at the moment of payment based on an underlying USD amount. So I could, in layman's terms, basically I would send a request for $500 in USD, but I want to be paid in USDC. So at the moment of payment, it's going to go out and check the USDC price oracle, and I'm going to be guaranteed to receive exactly $500 worth of USDC, even if USDC is slightly above or below the $1 peg at that exact moment. Some of the other features we support is escrow. You're able to escrow the funds. This is useful for a lot of like, I mean, you guys probably know what escrow is. Escrow is great for freelancers if you want to have proof of payment before work gets started and have those funds locked up into an escrow. That's super useful. And the other one that we support is being able to swap to pay. That's the idea where you are the request issuer, the payee, they want to get paid in, say, USDC, but the payer only wants to pay in DAI. What a swap to pay does is that at the moment of payment, it's actually going to go out and swap the DAI into USDC and then pay the USDC to the payee. Obviously, there's a little bit of slippage that's involved in that. We have our we use an aggregation service to make sure that all those swaps occur with the lowest amount of slippage possible. Yeah, that's I'll leave it at that for now. This guide here has some information about how to pay the request. For any of those given networks that I talked about, the payment methods that I talked about, all of them are going to have a pay request function. So when you create the request, you specify which payment method you want. And then when you pay it, you just call the pay request function, and it takes care of all the logic behind the scenes to make that occur. I'm going to real briefly talk about our payment detection stuff. Jump back to our quick start. If you want to detect a payment, basically we've excuse me. We've got a series of different subgraphs. Sorry, not different subgraphs. We've got a single payment subgraph definition that we've deployed to multiple different EVM chains, and we've got a link to it here in the detect a payment guide. If you jump over to that, it's going to have examples down here at the bottom of how to interact with it. Basically, there's this idea of a payment object inside the subgraph. And for each payment, you can look up the transaction hash, the gas price at the moment of payment, the contract that it was emitted from. So that's going to inform you which payment extension you're using. Escrow is going to be a separate contract from the ERC20s. ERC20s is going to be separate from the native tokens. That's what that's used for. It's going to tell you the block, the amount in crypto. So this is going to be like the underlying USD amount if you're using conversion. And then the amount in crypto is going to be the actual amount of tokens that is exchanged. It's going to tell you information about any fees that were taken out at the time of payment. It's going to tell you about the payment reference, the request ID, the to and the from address, as well as the currency that it's being paid in. So yeah, if you want to know more about the payment detection, definitely jump over to our payment subgraph repository, and I'll tell you all about it. Yeah, that's pretty much all I want to say about payment detection. So with what am I doing on time? I think I have some more minutes. I've lost track of the time. But I have a demo for you guys real quick. We have an application, a DApp that we call Request Create at the URL shown on screen. And it's a simple DApp that showcases how some of these features can be used together of the request network. Basically, it gives you the ability to create requests and then view all of the requests that you've created in the past. So I've got my test account here. You can see that I have created several requests in the past. All of them are in different tokens and different chains. Some of them are still awaiting payment. Some of them are still in progress. Actually, you know what? I'm not sure why it's showing up like that. Interesting. I'll have to take a look at that. It's supposed to show if stuff is paid already. Some of these I know are already paid, but I think that our production version of this app might not be as up to date as our staging version is. But so from the dashboard here, you can click into any of the requests and actually see more information about it, and you can share a link to that request. If it's unpaid, you can share the link to the payer to give them a notification that you are requesting payment. I'm going to real quickly go through the entire flow. So the first thing I want to do is I'm going to copy and paste my Bob wallet address because that's who I want to request funds from. I'm going to request from them 350 DAI. These are some of the currencies that the app is supporting right now. So DAI is an ERC20 on top of Ethereum. And I'm going to ask for a reason. This is just some metadata that I'm attaching to the request. Maybe DAI. So then I would want to create the request. And from there, it's going to request it's going to prompt me to sign the message. And we can see inside the message here, it's got all the parameters that I described earlier: the currency, the network, the type. It's an ERC20 transfer, the expected amount, and a bunch of other stuff. I'm not going to go too far into it. I'm going to go ahead and sign this. We're going to wait for the request to be created. Voila. So it has brought me to this new page where I can copy the link, and I could send this link to the payer. So I know that the payer was the Bob account. I'm going to just paste this here. Ooh, I just realized I created this as a payment for on Ethereum as a real request. I probably should have done a test request because I'm not going to actually pay 350 DAI right now. 1 second. I should have done this on Gorley. There we go. I'm just going to real quickly create another one. And that's the wrong thing. I need my Bob account. And I've just made another mistake. I realized I was attached to my Bob account, and then I requested funds from my Bob account at the same time. That's fine. We'll figure it out. It'll be a payment to itself. I think it'll still work. Okay, so I have the link now. I can copy and paste that over to my other tab. it's still creating the request in IPFS. So once that's complete, I should be able to pay it. There we go. So the request has been created in IPFS, and a hash of it has been stored on Gnosis Chain, or sorry, in this case, it'd be stored on Goerli. But now I should have the option to pay it. I click a single button. It figures out the payment network that I'm using. I have a pop-up here that's going to describe what's about to happen. I'm going to transfer one FAU token over to itself. I'm going to bump up the fee just so I don't have to wait as long, and I'm going to confirm it. And then we can see that the request becomes pending. We're waiting for it to be accepted on chain as a valid transaction. And in a separate tab, I can open up the Goerli transaction viewer, and we can see the progress. Excellent. It looks like it's been confirmed. In just a few more seconds, it'll hopefully be indexed on, and there it is. We can see that it sent one faucet token from Bob, and then it also sent it to Bob. So kind of a pointless transaction, but you get the idea. That's how it would work. Okay, so just a quick closing thought. The only other thing that I wanted to tell you guys is that we have a standing grant program at Request Network outside of this hackathon. So if you guys are interested in building with us, just know that we have additional grants available to builders who are building on our protocol after the hackathon ends. If you're interested in building with us, we'd love to hear from you. That's all the information I've got.
Awesome. Thank you so much, David. Yeah, really awesome. Great to have a very good overview of how to use request. Yeah, so we've got some questions. Okay, let's go through them first. So Nas asks, did you answer this earlier? How request does automatic tax reporting?
Right. Okay. So for tax reporting, one of the things that's a little bit difficult to assess is like which transactions are income versus some other type of payment. So that's really kind of what the request network is aimed at doing. It's a lower level primitive that would allow you to build an automatic tax reporting tool, but all of the tax reporting logic, that would all have to be part of the application that's built on top of it. The protocol doesn't itself provide that sort of information. Do you get what I'm saying? Yeah.
Awesome, cool. Next question from Nas. How do you do the conflict resolution for escrow? Did you answer this?
Sure.
As well?
So the escrow contracts, basically at any time, either party, the payer or the payee, has the ability to freeze the funds inside of the escrow, and that's done via a smart contract call. Once the funds get frozen, a timer starts, and I think if the payer freezes it, I don't remember the exact time frames, but I think it's longer for if the payer freezes it. If the payee freezes it, there's a shorter time period. And during that frozen time, I believe that I think at the end the payment will still go through to the payer, but the hope is that during that frozen time, the payer and the payee can come to some sort of resolution on their own. And if they can't come to a resolution, then the timeout, the time that the funds are locked, acts as kind of the punishment for either party for reneging on the contract, reneging on the payment agreement. Does that kind of make sense?
I think so. I think I will see if Nas has any other questions.
I'm just watching the chat.
Any docs? I guess.
Docs for the escrow. I'm assuming.
Yeah.
Yes. Yeah. So there is documentation for our smart contracts. I'm going to jump over to the GitHub real quick. For the smart contracts, you're going to want to go straight into the request network repository. Inside the packages / smart contracts. And then I think that there is this is going to bring you straight to the actual contracts themselves. I think that there's one second. No, that's not what I want. I apologize. There is documentation. It's kind of buried. I think there's a few different places you would want to look. You would want to look at the payment processor package. You would want to look at the payment detection package, and you would want to look at the smart contract package. And there's a couple of different escrow contracts for that.
Awesome. Cool.
Yeah.
Yeah. If there's any specific links as well that you'd like to share, feel free to drop them in the Discord later, David, or just pass them on to me.
Okay.
But yeah, NASA's saying no problem. Yeah. I think there were a few more questions. One more from Nas. During the demo, your request takes a while to generate, I guess because you store it on IPFS. Is it not just filling up IPFS with unnecessary data? Just want to hear your view on this and logic behind it.
Sure. So the purpose of storing that stuff on IPFS is to create a shared medium of exchange so that multiple parties are able to read the same data. But we also create the content identifiable hash, the CID, the content identifier, which is a hash of the data. The time that it takes to create the request is both the time it takes to store the data in IPFS and also the amount of time it takes to take that hash, the CID, and store it on chain, either on Gnosis Chain or on Goerli. So that's kind of where that time delay comes from. And I'd say that most of the delay is from the blockchain transactions. I think the IPFS stuff tends to be pretty quick.
Cool. I hope that answers
your question. The topic of filling up IPFS with useless data. Technically, the request network actually uses its own separate but still public version of IPFS. So it separates the request data out from the main IPFS, and that it was partially done as a performance for performance reasons to increase the speed of data lookup and data write. So as far as bloating the main IPFS, our requests are not bloating the main IPFS at all.
Awesome. Okay. I'm sure you saw the comment in the chat that Nas says thank you for clarifying. Okay. One more question in the questions tab. Katya asks, any plans for Sepolia?
Yes, we do plan for Sepolia. It's on my to-do list. We obviously Goerli is going end of life at the end of this year. Ideally, I would like to deploy to Sepolia well before that, but it's we've just got to do it sometime in the next 6 months.
Yeah. Work in progress. Awesome. Cool. Jade asks, sorry about that. Jade asks, is there a startup script to call the IPFS? Can we connect to the IPFS node of our choice?
Yeah, I think when you're creating the request, I think when you're creating the request network object, you have the ability to specify IPFS options. Where's the best way to see that? When you are constructing the request network, you have the, it's kind of buried a little bit. Here, I'll show you. Sorry, this is all very hectic. Inside the, here, I'll bring this back. So I'm inside the code for the, okay, here we go. Inside request network, packages, request client, API, request network.ts. That file, this is the file that defines the request network object. And basically when you're creating the request network object, you have the ability to pass into it the, where is it? Oh, it's going to be, it's not this one. I'm sorry. It's in the yes, there is. I would love to talk more about it after the presentation, Jade. Sorry about that. Are there any other questions?
No, I think I think that's pretty much it, and that kind of actually perfectly takes us to time. Yeah, thank you everyone so much for all of your questions and stuff, especially the ones that really get David thinking. Yeah, so I guess just a few little housekeeping things to wrap up. To everyone in the audience, make sure you've signed up for this hackathon if you haven't already. And more importantly, actually, I would say that you've joined our Discord group and are part, have joined the specific hackathon channel so that you can get all of the up-to-date information, as well as being able to contact all of our sponsors directly in their sponsor zones. David, thank you so much again. Happy Star Wars Day. And
yes.
It's yeah. Yeah, I hope you have a wonderful rest of your day. Thank you so much for speaking. And to everyone who's come along today and joined us for both the first and the second half, thank you so much. And stay tuned for the recordings if you want to go over everything. But yeah, any final words, David?
If you have any other questions about Request Network, I'm happy to help.
Awesome. Okay, well, with that, I guess we will end it there. So, oh, you're very welcome, Alex. Yeah, I hope to see you guys very, very soon. See you guys.